Still on number 5b. I have done the 5bi in the previous video. Now let's continue from 5bii. State 2 factors that determine the stability of a nuclide. The stability of any nucleus or nuclide is determined by 2 factors. Number 1, neutron-to-proton ratio. And number 2 is binding energy. Remember, the question says state, no explanation. Neutron-to-proton ratio and binding energy. These are the 2 factors that determine the stability of a particular radioactive or non-radioactive nucleus. And you know that radioactivity is a problem of instability. Once a nucleus is unstable, it will struggle to become stable, and that struggle leads to being radioactive. Now let me explain briefly what neutron-to-proton ratio implies and how it affects the stability of a nucleus. For lighter elements whose atomic numbers are less than 20, okay, let me use P, proton number, instead of Z. Those whose neutrons are approximately equal to their protons are stable. That is, those whose neutron-to-proton ratio are approximately equal to 1. Because if they are approximately equal to neutron and proton, it means neutron over proton will be approximately equal to 1. They are stable. And then for heavy elements, those whose neutron-to-proton ratios are approximately equal to 1.5 are also stable. That is neutron-to-proton ratio. Binding energy is the energy that holds the protons and neutrons in the nucleus of an atom, or the energy used to scatter them. Stronger binding energy means higher stability. Weaker binding energy means that the protons and neutrons are weak and can scatter. It means unstable nucleus. Now back to proton to neutron ratio. Too many protons or neutrons leads to instability. And like I said before, instability leads to radioactivity. Now I will give you an assignment. Using neutron-to-proton ratio, which of these is the most stable nuclide? Carbon 12, carbon 13, and carbon 14. Is it carbon 12, carbon 13, or carbon 14? You know, from the mass, you know how many protons and neutrons. Just do the ratio and find out the most stable and the least stable, or the one that is radioactive. Please share this video as wide as possible. Tap on follow button if you are on Facebook or TikTok, and subscribe to my YouTube channel.